Okay, pre-cal students, in this video we will be studying two different ways to divide polynomials. One method is called long division and the other method is called synthetic division. Okay, so we're going to look at two different ways to divide polynomials today. Your heading today is Polynomial Long Division and Synthetic Division, Lesson 2.3. Be sure and include today's date in your notes so that your notes are organized. Okay, this should look familiar. You did have this in Algebra 2, and the difference between this and Algebra 2 is we go a lot faster. In Algebra 2, this would have been taught one day, and this the next day. We're teaching both of these in one day. Then we're going to go on tomorrow and apply that to zeros and polynomials. Okay, alright, so it should look a little familiar. Let's start off by studying long division first. I am only going to give you 3 examples, and then I want most of your learning to come from working your homework problems. Okay? Now, before we get started, I want to warn you that we are going to be using long division and synthetic division for other things, so you really need to know these two procedures today so that when we use these in the future, you know how to do that. Here's the first example. Alright, now let's go ahead and write this in long division form. First of all, always learn to write your divisor and your dividend in standard or general form, okay? So here's my divisor. I'm dividing by x minus 2. Standard form means I write the highest exponent first of my variable. In other words, my variable comes first, then my constant term. Now also, write the dividend, this right here, the dividend, what goes inside the box, write that in standard form. So your highest exponent comes first, cubed, then your next highest, squared, then your next highest, 16x to the 1 power, and then your constant term. Okay? Now some teachers teach to put zeros in if there's a term missing. For example, pretend there is no term here. Then the teacher would encourage you to put right here plus 0x squared. That's a really good method. There's nothing wrong with that. I used to teach it that way, but the problem is you get a lot of extra terms in your answer up here that you necessarily don't need. Zero terms sometimes, so I don't teach it that way anymore, and I would like to encourage you to give my method a shot before you just throw it away, okay? Alright, here we go. So step 1, and I would encourage you off to the side somewhere in your notes to write down steps. Step 1, make sure your divisor and your dividend are written in standard form. You must always do that first, okay? Alright, moving on. Next, always divide your first term into your largest degree term. In other words, it's going to be your first term, so divide your first term into your first term. Okay, so here we go. How many times does x go into 6x cubed? Well, the answer is 6x squared. So you write that up here. Now, some of you are like, Mr. Era, where'd you get that from? Let me show you. You're taking this term here, 6x cubed, and you're dividing it by x, okay? Always take your first term and divide it into your first term, always. So, look what happens. If I have 6x cubed over x, take away 1x, take away 1x, and I'm left with x squared, 6x squared, okay? So if you need to do that off to the side, don't feel dumb. Feel free to do that, okay? Alright, so anyways, a lot of teachers also like to teach to move this over based on how many terms. If you have 2 terms here, then put this over here. I don't get into that either. The less things I have to make you memorize, the better off I'm going to be, okay? I want to keep this as simple as possible. Step 1, make sure your divisor and dividend are written in standard form. Step 2, divide your first term into your first term. Okay, now, next, just like any math, any division problem, if you're dividing 3 into 762, 3 goes into 7 2 times, right? I'm going to keep this down here for us to look at, okay? What would you do next in this old-fashioned division problem? If you put a 2 up here, what would you do next? Wouldn't you multiply 2 times 3 and put the 6 right here, right? Well, let's do the same thing. Let's take this times this. this, okay? So 6x squared times x is 6x cubed. 6x squared times negative 2 is negative 12x squared, okay? Very good. Now, let's come back down here to our basic division problem. After you took 2 times 3, which is what we did up here, we took this times this. After you multiply, don't you subtract next? 7 minus 6 is 1. Isn't that correct? Sure it is. So let's subtract. Now be careful you're subtracting. Watch your signs. 6 minus 6 is 0x cubed. In other words, it canceled out, so cross them off. Now be careful here. Negative 19 minus a negative 12 is really negative 19 plus 12, so it's negative 7x squared. Now, here's what I'd like to suggest to you. Instead of subtracting, there's an easier way to do it. I would recommend, instead of subtracting, you change the signs here and you add. That's the same thing as subtracting, and it usually lends itself to less mistakes. But I first wanted to show you that we really are subtracting, just like in a regular division problem, okay? Now, that's up to you. If you want to put a minus sign here and take 6 minus 6 and negative 19 minus a negative 12, no problem. For me, though, I'm going to change the signs and add. So here we go. 6 plus negative 6 cancels out. Negative 19, positive 12, negative 7x squared. Got it? So pretty good so far. Now, a lot of teachers next teach you to bring down this next term. I don't care for that. I'm going to tell you why. In this problem, it works out real nice and pretty because you've got a third, then a second, then a first degree, then a constant term. Here you've got a first degree, then a constant term. So this is pretty much a cake type of problem, okay? I don't teach to bring down the next term. Let me review. I teach to divide first term into first term. Whatever you get here, multiply it, then subtract, and now repeat the process. So I know in a normal division problem, you would bring the 6 down like this. I get that. And to be honest, you can bring that down if you want, but sometimes it lends itself to problems and examples like this and examples like this. So I just want to warn you, I personally will just divide first term into first term and do the whole process over again, okay? That's my suggestion. So here we go. Let's repeat the whole process. Divide first term into first term. X goes into negative 7x squared. Negative 7x times. If you want to see that, it's negative 7x squared divided by x, okay? Your x would go into your x one time. Negative 7x to the 1 power, okay? Alright, now, so put a negative 7x up there. Now, we're going to take this right here, alright? It's negative 7x, and we're going to multiply it times x minus 2. We're just repeating the last process that we did, okay? So here we go. Negative 7x times x is negative 7x squared. Negative 7x times negative 2 is positive 14x, okay? Now, listen to me, students. Now that you see what kind of term you have here, then bring down your next term. I have no problem with that, okay? That's fine. But I always wait to see what this term's going to be because you want like terms to match up with like terms. So now that you see that the 7 times 2 is 14x, now go ahead and bring down this x term. I have no problem with that, okay? That's fine. So there we go. Now some of you are going to subtract, which is fine. I'm not. I'm going to change the signs and add. That's how I'm going to do it, okay? Negative 7 and 7 is 0. They cancel out. 16 minus 4 is 2. 2x. Now some students bring down the next term. I'm not going to do that. I'm going to wait, okay? So x goes into 2x 2 times. If you want to see that over here, 2x divided by x, your x's would cancel, leaving you with 2. Now take your 2 and multiply it through. 2 times x is 2x. 2 times negative 2 is negative 4. You have a constant term here, so feel free to bring down your constant term, okay? And by the way, when you bring them down, it's probably a good idea to put arrows so that you only use them one time. It's probably a good idea. Okay, now you're welcome to subtract, or I'm going to change the signs and add. These cancel, you're left with 0. Now, how do you know that you're finished, okay? Well, you know you're finished when there's a couple things. Would you please listen to me carefully? First of all, you have no more terms to bring down. That's the first thing, okay? And we have no more terms to bring down. Secondly, when this degree here, now we have a 0, right? So that's really 0 x to the what power? 0, okay? When this degree here is smaller than the degree you have here, then you know you're done. Because common sense, guys, common sense. How can you divide a first degree into a 0 degree? It cannot be done, okay? Not without negative exponents, and we don't want that, okay? So, you know you're finished when there's two things, okay? First of all, when you've brought down all of your terms, and we have. Second of all, if this term here, if the degree is smaller than this degree here, then you know you're finished. Both of those things, okay? Alright, so there's your answer. Not too difficult. That's a pretty easy problem, to be honest with you. Now let's go a little more complex, alright? You can work ahead or watch me. Here we go. Work ahead or watch me. Alright, here we go. Step 1 is write your divisor and dividend in standard form. So we're dividing by x minus 5. That is in standard form. Now let's write your dividend in standard form. And this is in standard form. There we go. Okay? Alright, now let's go ahead and get started. Here we go. And again, a lot of teachers teach you to put a 0x squared and a 0x in the negative 1. That's fine, but that does tend sometimes to waste space, take up a little bit of time, and give you some 0 terms in your answer, which is not necessary, okay? I think if you'll use this procedure, you'll be just fine. Okay, standard form, so we divide first term into first term, okay? So x goes into x cubed, x squared times. Now, I'm not going to keep doing this for you over here off to the side. If you need to do that on your own, okay? I'm not being mean, I'm just saying. I'm not going to keep doing this for you, okay? This will be the last time I'll do this, and then you can figure it on your own. So x cubed divided by x, okay? Was this, take 1x away, take 1x away. You're left with x squared, so I put an x squared here, okay? So x goes into x cubed, x squared times. Now you multiply x squared times x cubed. Now watch, be careful. X squared times negative 5, negative 5x squared. Notice we do not have like terms here, and that's okay. Don't worry about it, okay? No big deal. I can handle that. So just watch what happens, okay? First of all, I'm going to change my signs and add. Okay? These cancel. I have nothing to combine this with, okay? So I bring it down. That's it. It's a piece of cake. I don't think you need all those zeros up there. Just bring it down. Now, let's go ahead and divide first. It's that easy, guys. Now let's divide first term into first term. X goes into 5x squared, 5x times. Now let's multiply 5x times x, 5x squared. 5x times negative 5, negative 25x. Now, this is an x term right here. If there was an x term up here like negative 3x, then you would bring it down. But you don't have that, so don't worry about it. Just keep going. It's no big deal. Go ahead and subtract. Now, some of you are going to subtract. I'm going to change my signs and add negative, positive. So these cancel. There's nothing to add with 25, so just put 25x. And guys, keep right on going, okay? I know there's a negative 1 up here. When we use it, I'll draw an arrow, okay? Until then, I'm not going to worry about it. Now divide first term into first term. X goes into 25x, 25 times. 25 times x, 25x. 25 times negative 5, negative 125. Now, this is a constant term. Is there a constant term up here we can bring down? Yes, right here. So let's bring it down. Negative 1. There we go. No big deal. Okay? No big deal at all. Now, let's go ahead and change our signs and add negative, positive. And so, these cancel. And you're left with positive 124. Now, here's how you know that you're finished. First of all, there's no more terms to bring down. Second of all, your highest degree here is not higher than 1, so you can't divide x into anything else, so you're finished. So now what do you do with the remainder? Well, one thing you don't do is you don't do like you used to in elementary school and put remainder 124. That's kind of funny, okay? You don't do that. That's elementary school. What you do is, well, let me ask you a question. If you divided 3 into 5, watch this. You would put a 1, you would multiply, and your remainder's what? 2. What do you do with that 2? Don't you put it over the 3 and you put 2/3? Is that what you do? Sure you do. 5 divided by 3 is 1, and you take your remainder, put it over the divisor, 1 and 2/3. We'll do the same thing here. Take your remainder and put it over your divisor. So put plus 124 over x minus 5. And now we're finished. There we go. One more of these, then we'll get into synthetic division, okay? One more of these. Alright, here we go. Let's write our divisor in standard form. Highest power first, then your next highest power, and then your constant term, okay? Next, write this in standard form. So your highest power first, then your next highest power, then your next highest power, then your next, then your next. Alright, and here we go. I don't care if there's a trinomial out here. That's no big deal. Everything is still the same. You write your divisor in standard form, write your dividend in standard form, then you divide first term into first term. Nothing changes. So 2x to the 4th divided by x squared is 2x squared. Okay, if you don't see that, work it out off to the side. Now you take your 2x squared and multiply it through this trinomial. So 2x squared times x squared, 2x to the 4th. 2x squared times 2x would be positive 4x cubed. 2x squared times negative 3, negative 6x squared. Notice all of your terms are like terms. They line up perfectly. And so we're good to go. Let's go ahead and subtract. Or in some cases, like me, I like to change the signs and add. That's how I do it, okay? Whatever you want to do. These cancel. And look, these cancel also. No big deal. So now we're left with positive 6, negative 5. That's a positive 1x squared. And you do not need to put that 1 if you don't want to, okay? Now again, a lot of teachers, in my opinion, get hung up in bring down your next term. Look, I don't care about that. Just leave it like it is. Divide first term into first term. So x squared goes in x squared one time. 1 times x squared is x squared. 1 times 2x is 2x. 1 times negative 3 is negative 3. Now, we've already used this term here. Bring down your 3x because they're like terms. Bring down your constant term because they're like terms. And now we're good to go. Here we go. Change your signs and add negative, positive, and then change this to a positive, okay? So these cancel. 3 minus 2 is 1x. Negative 2 plus 3 is a positive 1, okay? Now, having said that, how do I know that I'm finished? Very simple. First of all, make sure you've used all your terms and brought them down. If you haven't, bring them down. Okay? Just make sure this expression here is written in standard form. You want your highest power first. Secondly, I've used all my terms. Secondly, if this power here is greater than this power here, then you know you're done. So you're finished. So this expression here is your remainder. So in your answer, you put plus x plus 1 over x squared plus 2x minus 3. And there's your entire answer. Okay, students? Alright, now let's move on. Now, let's take a look at another method of polynomial division. To be honest with you, it is an easier method and a quicker method. So why don't we use this method instead of long division? Well, here's the problem. Synthetic division can only be used in certain polynomial division situations. Long division, although it is harder, can be used in any polynomial division situation. Let me start off by showing you when you can use synthetic division, okay? And then I will show you how to use synthetic division. Alright, here are the requirements. outside the box. Okay, this part right here. Okay, your divisor must be a linear binomial. I'll explain that in a second. Okay. Requirement number 2, your lead coefficient must be 1. If you have those two scenarios, then you can use synthetic division. Now again, I'm going to explain what this means in just a second when we solve our first problem. I'm going to show you what that means, okay? So, the requirements are your divisor must be a linear binomial and your lead coefficient must be 1. So here we go. Let's try 3 of these and we'll be finished. Okay, problem number 1. There it is. Now, before you start using synthetic division, go to your divisor. Here it is, x minus 2. First of all, it must be a linear binomial. Well, is it a binomial? Yes, it is. Is it linear? Yes, because your power is 1. That's what I mean by linear binomial. If this power was a 2 or a 3 or a 4, then you can't use synthetic division. Your divisor must be a linear binomial. Number 2, your lead coefficient must be a 1. And is it? Yes, it is. So we can use synthetic division on this problem. Watch how much faster it is, okay? First of all, you want to make sure that your divisor and your dividend are written in standard form, okay? If they're not, quickly cross them off and fix them, okay? So if you're writing down steps off to the side, that is the first thing you want to do. Make sure both your divisor and dividend are written in standard form. Got it? Number 2, whatever the sign of this number is, you always change it. Always. So put a positive 2 here. Alright? Now, sorry, it should look like this. There we go. Now, you take your coefficients and you list them out. Okay? So let's review. And your constant term too, let's review. Step 1, make sure that your divisor meets the requirements for synthetic division. Step 2, make sure both your divisor and dividend are written in standard form. Next, always change the sign of this number here and put it over here. I'm not going to get into why you do that. I can explain that. It does have to do with something like this. X minus 2 equals 0. Set equal to 0 and solve, you get 2. That's why I use it 2. That's all I'm going to say for now. I'm not going to get into all of the reasons on that, okay? But change the sign of this number and put it here. Then you list all of your coefficients here. But listen, if you're missing any terms, you must put a 0. And we're not. We have a third power, a second power, a first power, and a constant term. So we're totally good. So put your 6, put your negative 19, put your positive 16, put your negative 4. Now watch how fast this is. Bring down your 6, and then you multiply and add over and over and over. You multiply and add over and over and over. 2 times 6, multiply, you get a 12. Add, you get a negative 7. Multiply, you get a negative 14. Add, you get a positive 2. Multiply, you get a 4. Add, you get a 0. Now that's fast. This number here on the end, make note of this please in your notes. That is always your remainder. So in this problem here, there was no remainder, was there? Not at all. Now what do you do with these numbers? They're coefficients. Whatever your degree is right here, your 6, you go 1 less. So it was 6x cubed. So you're going to put 6x. What's 1 less than 3? 2. Then your next coefficient, it would be negative 7x. This would be your constant term. And there's your remainder, nothing. Okay? Now, did you notice, this is the first problem in your notes that we did. Did you notice that or not? Go back to the very first problem in your notes. What answer did you get? 6x squared minus 7x plus 2. Now look at what answer you got with synthetic division. 6x squared minus 7x plus 2. The exact same answer. So the exact same problem, done 2 different ways. Look how much faster that was than doing that other method we used way up here. That took a long time. So synthetic division is definitely better when you can use it, okay? So when you can, that's fine. Alright, when you can't, well, you'll have to use long division. Alright, let's go on to another problem. Alright, here we go. Is it linear? Yes, I have a power of 1. Is my lead coefficient 1 right here? Yes. So I've met the requirements for synthetic division. Now, is this written in standard form? Yes, it is. I know we're missing a term right here. I know that. But that's okay. It's still written in standard form. Okay? So is this written in standard? Yes, a 4, then a 2, then a 1, then a constant term. Is this written in standard form? Yes, it is. So we're good. Change the sign of this number here. So I'll put a -3. Then we're going to write all of our coefficients, but don't forget, the coefficient of the x to the 4th right here is 1. But then next you're going to put a 0. You're going to put a 0 because you're missing an x to the 3rd. So 4, 3, 2, so put a -10. Then 1, so put a -2. And then your constant term 4. By the way, are you listening, students? If you didn't have a constant term right there, you would have to put a 0 there. A lot of students miss that on a test or quiz because they see the 4, 3, 2, 1, and they forget about a constant term. If there's no constant term, you must put a 0. And now we're ready to go. Watch how fast this is. You bring down your first number, and then you multiply and add over and over and over. Multiply, -3, add, -3, multiply, -3, -3, add, -1, multiply, -3 and -1, add, multiply, -3 and 1, add. There we go. Now, this first term right here was a 1, x to the what? 4th. So go 1 less than that. 4 minus 1 is 3. So we're going to start off with a 1x cubed -3x squared minus 1x plus 1. Remember, this is your remainder right here, right? So then plus, and your remainder goes over the divisor, x plus 3. That is so much faster than long division would have taken you. One more and we're done. Alright, here we go. Okay, step 1. Let's make sure that our problem meets the requirements of synthetic division. Do I have a binomial here? Yes. Is it linear? Yes, it is. Even though it's written out of order, your power of your x is still a 1. So yes, it's linear. And yes, it is a binomial. Next, is the lead coefficient 1 right here? No, it's not, Mr. Earth. There's a 2 here. Now, guys, don't forget when I say lead coefficient, I'm talking about if this was written in standard form, like this, then do we have a lead coefficient of 1? Yes, we do. So yes, we have a binomial. Yes, it's linear. And yes, our lead coefficient is 1. Step 2, write your things. Write your divisor and dividend in standard form. Well, this is not in standard form. I'll quickly change that. 5x cubed plus 8x squared plus 6x, okay? Now write this in standard form, x plus 2, okay? So there we go. So step 1 is done. Step 2. Step 3, change the sign of this number here and put that right over here. Okay, next, write all of your coefficients down here. 5x cubed, then squared, then 1, so we're looking good. 5, 8, 6, but remember, there was no constant term here, so we have to put a 0 in the end. Alright? Now, students, here we go. Always bring down your first number. That's the first thing you do. Then after that, you multiply and add over and over and over. -2 times 5, -10. Add these two, you get -2. Multiply -2 and -2, you get this. Add these two, you get this. Multiply -2 and 10, -20. Add those two, you get -20. Alright? So this is your remainder right here, -20. Now, this 5 was what degree? It was a 3rd degree. 5x to the 3rd right here. So go 1 less than that, and that's going to be 5x squared minus 2x plus 10 plus the remainder, -20, over x plus 2. Now, students, I want to be very clear about something. To me, this is a perfect answer. Beautifully done. Well done. It's awesome. However, most textbooks are going to want you to do this. Whenever you have a negative sign for your remainder, they're going to want you to they're going to want you to sign there and make the remainder positive. So instead of putting a negative 20 up here, they're going to want a positive 20, put a negative sign here. Now for me, Mr. Earhart, I don't care. I am totally fine with this right here, but I want you ready for higher level math classes and other teachers. So in the back of the book, you would have probably seen this right here. Negative sign here, 20 is positive, so get used to that, okay? But if you write your answer like this, I have no problem with that either, okay? Alright guys, hope this video's been a help. If you have any questions, don't hesitate to call or email.